Welcome everyone to Living the Open Source Dream here live on this channel today with latest Rust 166 stable as well as Kexec. Rust, of course, a newer, more modern memory and safer language. Out with the usual improvements. I already test built that prior to this live stream. Here for our T2, just amazing open source Linux distribution, and so yeah, that builds that has new explicit discriminations of enums with fields and Coriant black box and other amazing, super amazing stuff. Cargo remove, stabilized APIs, other changes, super amazing, as well as all our patches still apply. Firefox also builds, so there you have that for one of the best Linux distributions playing along at home. And then I noticed, of course, I'm using Kexec as long as, like, I'm being on Sony's other OS Linux on the P3, one of the first users of Kexec. Of course, since then, 15 years ago, every x86 stuff in servers are probably using that. If you don't know what that is, this is Kexec for Linux kernel execution. That means you can boot into another Linux kernel without going through the BIOS. And so usually BIOS of multi-socket CPUs and quad channel or octa channel memory and stuff at times, or like dozens of storage. Often BIOS, post and boot and stuff can easily take 2 minutes or more, especially the bigger the IBM and Sun Iron there is longer. But even on Epic Threadripping, latest and greatest Ryzen, especially 7950X here, my latest overkill build, the post often takes more than 30 seconds, right? So you have there 30 seconds, like up to easily even Intel DDR5 memory training and stuff, a minute or so, especially if it's a more over memory subtiming, overclock and so on. Long story short, I noticed, so basically I wanted, usually I don't use Kexec on my normal workstations and stuff, but given that the post is so long, plus I still don't understand, especially with the Ryzen AM5 7000 series, some of the performance, each time I boot, the performance is different, right? It's turbo boosting differently. So basically I want to cut through all the the less BIOS, previous more main video, right? The less BIOS bullshit, the better. And I wanted to test if I get more stable boosting, and especially like sometimes I have a state like where it's like boosting significantly better, like over 100 megahertz, 150. And I certainly don't want to use it, right? So, and I noticed now, like, we have a new issue here, handling RELA relocations. And so I Googled that, I know the fix already, so we don't need a long debug session. Just as somebody like this is recurring stuff, right? It's only constant change. Like you use Kexec for 15 years and then 2022, more. What happens here is I Googled that, other people had that, even Fedora, if you blame my tiny little, one of the most amazing Linux distributions, according to my best friends anyway, before you blame my amazing Linux distribution, no, it also happened to Fedora at times. So what happens is, according to my preliminary analysis, and I tried that already, that if we build Kexec tools, I probably built that, let's do that again. And so now we build with more stuff. As also also best without caps lock. How did I press that? So what happens here is, like, we build now with more stack smashing protector and Pi, and so some of this code, like a tiny fraction. So normally I thought all of the stuff is user space, right? Like loading the data. So look, what happens is this Kexec tools loads this data in memory and then tells Linux kernel, hey, I have here some memory. Can you, when you then Kexec system called Kexec on reboot, like you shut down your system, and then at the end, hey, like, can you please not, instead of reboot, Kexec that and cutting all the BIOS bullshit and directly booting into the next Linux kernel. And I thought it's all user space, but it turns out there is a tiny fraction of some piggyback trampoline thing. I didn't look into that. It's according to my Google finds that is loaded into the kernel of all things. So even I regularly learn something new. And so because of course it's optional in T2 with our amazing configuration system, but I changed the default to, at least for most platforms where it's supported, for stack smashing protector and Pi for full randomized user space, address space randomization. And so apparently, what did I even do here? Is that even, what did I? Apparently not that one. So there is some fraction of code that is run into the kernel, so we can't Pi and stack smashing protector that. The question is how easily, so an easy fix is to, purgatory. So let's see how much that is. Okay, there are a handful of files. So the question is, how do they build that? Because I don't really want, so an easy fix, what I tried already, is like just flex this package Kexec tools of no Pi, no SSP. That works. But that also builds then, that would be the slash hammer of, also I have too many dongles on my cables, dongles. Do you even right microphone? Nothing like dongles on your tail. So of course we want at least the surrounding Kexec stuff to be stack smashing protected and Pi. So let's see if, do they build that with absolute passes? So we would need some, so they do here GCC, and so yeah, they have here special kernel like code model and stuff. So yeah, it appears that that is using, where is it, GCC? Or do they even, what do they do here? Oh, purgatory. Yeah, so we are lucky that they use not relative, like often old-fashioned build stuff would change directory into that, and luckily they built that at least here with absolute path names, so that we probably can match that purgatory. So Kexec, so that would be Kexec Arch. Funny that they built this with OS though. So the only issue I hope that OS is, I mean, usually it shouldn't be. I mean, okay, we could actually, so what I wanted to, okay, long story short, I get as usual. Just, I see some stuff in my brain already matches the next things. So we can probably easily match on purgatory. The only thing is we have Pi, and so yeah, this are one argument options. So we can either match on purgatory because the way they built that here, thankfully, by pure chance and accident. We could also match if that would not be the case, or otherwise if we want. Actually, they have here no pick and no Pi. So either we do that, or we match on freestanding or no Pi. Or potentially having, so yeah, they are, as usual, there is not like one golden way to fix something. There are usually a handful. So either we could also change our Pi, and I wonder though with LTO, because theoretically we also LTO. What is slightly older system? I wonder if that, because with LTO we also have full program, and but did I had a VM running. Where is my VM? All right, I unplugged this. Yeah, so let's probably try that. And let's take a look into the log. So we probably, yeah, so we do fpi, we do a little bit, lots of stuff there. So yeah, because it's using append, how do we do that? I mean, we could simply transform that and prefix that. The only thing is that another complication here with our T2 Linux distribution is always that historically, like everyone just used, because we have insert, append, like insert is in the beginning and append is at the end. And sometimes the order is important, which is why we have both. And historically, like every developer just used something until someone realized it didn't have work for something. But yeah, if that is moved, because I'm also thinking like if this code is moved from insert to append, what is even, so append is fpic, the question is, do they build this with no stack protector? Actually, maybe it's mostly stack protector strong. Do they also do that freestanding? Actually, they do no stack protector. They even do no tree vectorize. Interesting. The question is whether that works. Should work if fpic is the only offending thing. But I mean, because we do, why do we add that at the end? I wonder if, I mean, as they add so many explicit things, the question, I mean, I could quickly try, but only, should I so close? I mean, basically, I'm like an hour before I want to release build everything. If I change the order of fpic, why do we do pi, config static, static pi, why do we append that? Does it need to be at the end? Probably not, huh? The question is, does that override? That could potentially be enough. Otherwise, I'm just not entirely sure. Do I really want to change such a major? So only constants change and regressions. I mean, maybe it doesn't help anyway. Then how do I not have history? Hello. Ah, that is already enough. Interesting. Then the questions, I mean, I will notice on a full rebuild if, and then to execute this, so in your sys5 init, if you've never done this, either you like Kexec execute that now, or you have init and like reboot K or stuff, shutdown, I think shutdown K0 pro, does then Kexec if you have a patched and stuff sys5 init or systemd. Yeah, I guess wipe the build and see if that is enough. Did I? So yeah, that's a thing. Should we maybe take a closer look what this purgatory actually does? Is it written like this or like that? Add zero initialized NBSS issue is create hold code between, so code between kernels, whatever precisely. Actually, first time I quite interesting stuff. Probably memory space char digit purgatory. I'm in purgatory. Yay! Verify. Post verification setup arch. Interesting. Doesn't look like the most whatever that is. By the way, notice one thing. Maybe we patch a tiny little thing. Maybe violated one bonus because obviously you're here for the best Linux distribution, and we continue our attention to detail and dedication to continue advance our T2 Linux. And I noticed that if you kexec a elf kernel, I think, and so this error message is not new line terminated. Let's quickly fix that. It's like why has nobody ever patched that before? 2022, only live on this channel, fixing major primary all big mega corporations Linux server and virtualization tool and stuff. Diagnostics. Why we are always those who notice that, I don't know, or people at IBM and stuff simply don't care. So that was, what was the message? Why do I even have that now? Disk not supported. Or is it somehow interesting? Why do they print it? It's somehow architecture specific. So probably, maybe even it's, don't tell me it's difficult to go to out, die this error message. I guess so much too. I thought maybe it's in purgatory and it's difficult to get that from in kernel to, but no, it's just like, I guess, error message. Should we actually, no, here's this error, other error messages haven't. I mean, so I would like maybe have the error message, like, I mean, just looking there, it's like the next error message is new line terminated. So back to the drawing board, error message. So, an argument. So this is only two. It's a little bit lame. Okay, fine. Where is the other? Should we maybe fix, like, violate it? Let's be professionals. Kexec arch, kexec elf. Kexec, oh, this, oh no, arch. Oh, there is. So, oh, there are quite some. Oops. Okay, let's not do that. Was it x86, or how do they call the other one? Oh no, they call it i386, or no? What the heck? Message. But let's, as I already didn't go through all of them, let's at least grab that. Is obviously faster than going through all of them manually. So do we find other? So, and then error message equal, and so there are not so many theoretically. I know we have already, okay, let's .c, it's not our vanilla, and then theoretically grab, negate, That somehow doesn't so much do. Okay, let's visually, what does this again not work? Should this not? Okay, fine, whatever. /n. So this was really the only, so like with my luck trying some random stuff, and somehow we always, maybe instead of computer scientist, programmer and manager, maybe I should have been quality assurance tester, probably some talent lost in QA testing as we find everything. There's a feeling different distros maintain repeating the same work for each distro. Is that true? Well, kinda, right? 99%. I mean, yes, I say this a little bit, especially with all the low quality stuff. I have the feeling a lot of, but I mean, no, this is the tiniest thing, right? Obviously, writing all the Kexec stuff is 99% of the stuff that is upstream, so it's only. But I would agree that this last 1%, the last 1% imperfection, all the 1,959 distributions need to repeat. I mean, unless I want to have hashtag #peatbugs, but this is obviously kind of the reason why T2 with all the architectures like becoming kind of reference material of looking up how stuff should be done and is fixed. And I probably should send it upstream to Ken check submitting a patch to Kexec tools on my bucket list. Let's do that again. And probably kind of sort of call it a day, right? I mean, we have some people tuning in, which is amazing. Kexec. Like, is it not amazing if your error message is new line terminated? What a feature. I love it. So yeah, that's it for this video. Kexec, did I add that? I guess I can spin a new ISO, run it through. I mean, theoretically, we probably could, becoming so professional and people wanting to buy into T2. I probably do. Where's my test set stuff? Did I put all the test ideas in here already? I lose overview. Somewhere I had all my tests. I currently have too many, so many advancements that I already run out of. I'm overflowing my to-do files. So I had Kexec here. At least I thought I have it here. Okay, I had it in some other file somewhere. So I have kind of sort of done that. So over the last nights, I flagged probably 100 more packages to cross-compile in T2, but just like embarrassingly epic thread ripping, trying to cross-compile everything, and of course, still 50% or 40% doesn't build, but at least we found hundreds that, due to all the advancements in T2, and people never tested that, packages that cross-compiled. So test Kexec. I wonder which other machine did I had. Might be on my. Yeah, I need some better storage area network here. That it's not scaling anymore. I do too much. I do way too much work. Yes, Kexec. I mistyped. Darn it. Okay, that's done. Test PS3, real iffy. All right, actually, I know I meant test. I probably just added that so much to my short-term memory unit test. Kexec. Then we would have noticed it if I would have had a unit test for that. So coming up next, more unit tests, obviously. So Rust committed, how much other stuff? Alright, so the so basically the what did I have in those files? Alright, I wanted to so in the future, tiny little small change. I changed that already for our default kernel, but I also changed the default hostname from localhost to T2 just to have a better branding experience that if your system comes up, it's named T2. Tiny little things, still need to test if that. I hope that doesn't cause a regression, but I think it shouldn't. Just a tiny attention to detail after 25 years. It's probably a nice thing to do. I have some builds, which I need to redo anyway. Why do we test all this stuff now? We're also waiting for the kernel. It's still waiting there. So yeah, that's basically it for this video. Leave in the comments below your questions, remarks and stuff. I hope you enjoyed this and learned something. Basically wrenching here T2 open source Linux plumbing every day. And don't forget to subscribe, GitHub or Patreon sponsorship or otherwise. Looking forward to see you for the next videos and live streams, and have a good day or night.